Hello and welcome to another video where we are going to work through an example by hand. This time we are looking at topic 10, which is on correlation. And I assume, like with all the other example videos, we've already worked through and understood the lecture video that I call part A. This is the follow-up where we work through slowly by hand a typical problem. As always, the book we're going to talk about or use for these problems, the very good Statistics for Psychology book. Best explanations as far as I'm concerned for these introduction topics. We're on page 485. Now the instructions, we're going to do number 12, but the instructions for the following three questions are up here above number 12. Now it's wordy, but let's just get an idea for what we're going to be doing roughly. We are going to have two variables, and we are not going to have a lot of sample scores because we're doing it by hand, and we're kind of limited for that reason. We first want to just visualize the information by way of a scatter diagram. Then we're not going to write it out, but we'll just say what we observe and what we think might be happening here, even in the very small sample case where it's difficult to visually say much. Then we're going to calculate the correlation coefficient and also check if it is statistically significant, of course. But one thing at a time. Let's just write down our information and slowly work our way through the typical question. So in number 12, we are investigating a possible correlation between dexterity and anxiety for just a few people, 1, 2, 3, 4 people. In this case, I'm going to let dexterity be my X variable, dexterity. And the scores we got for the people 1, 1, 2, 4. And then I'm just going to give myself some space here. I think over here should be sufficient for my other variable, which I'll represent with a Y, anxiety. And the scores we got there were 10. What did we get? 8. I have my notes here, so I don't have to flip back and forth between the problem information, but you see there I just copied these down like so. Next, I'll do it below here. We want to, according to the question, have a scatter diagram to visualize. I'm just going to put this line a little higher, sorry. To visualize what's happening here. That doesn't mean we can make any conclusions based on this, but it's good to, oops, that's a Y, right? It's good to have some visual assessment of what could be happening here, and then we test it on a more technical level to confirm our possible suspicions. So I'll mark off looking at our Y values here, our scores. They go up, they go to -2 and then up to 10. So let's make 10 the top here. So we'll break it up into, let's say, not too many, but 2, 4, 6, and 8. This, of course, is 0 for both. And then if I look at the X scores, they only go 1 to 4. So I'll make that a little wider because I have space there. The scale does not have to be the same, of course, like so. So our first data point, dexterity 1, anxiety 10, that sits up here. Second data point, 1 and 8 over here. Again, just a rough sketch here because we're not doing much with it. We just want to visualize. But of course, in software, this can be done for many more data points. 2 and 4, roughly over there. And 4 and -2, put that over there. So looking at this, I know we don't have a lot, so it's hard to say, but it might suggest a negative correlation. You see that it might suggest a line slanted like this, which indicates a negative correlation. How strong that correlation is, of course, we don't know until we go and calculate it. So that is just our introduction portion, really. So next we want to, I don't have a lot of space here, but I'm going to try and squeeze into 2 columns. Next we want to calculate the mean and the standard deviation for the sample of X values and Y values, and then standardize each set to their corresponding z-scores. I'll put that over here with some space in between to explain how we get from the score to the standardized z-score. And then we're going to combine these 2 z-scores by multiplying them together for each person, and that is eventually going to give us our correlation coefficient. Now, our formulas are a little bit limited here, but we look at 11.1, which is our correlation coefficient. You see we add up those products of the z-scores over all the people in the study, and then divide by the number of people. So once we have those, our correlation coefficient will be pretty easy to calculate. Okay, now let's look at X first. How do we get the z-score again? Now, of course, we've done that by looking through something that was calculated already for us, but be careful, it makes a difference if you have just a blank, empty page and you have to now do the calculation. It can be deceptive, so definitely work through it by hand and don't just watch a slide, watch me do it. Eventually, we're building up to where you can do it from scratch. So it's a couple of steps here. Now I don't have a lot of space. I'm just going to quickly sort of show you what is happening inside here. First of all, let's calculate the mean X score. We just add them up and divide by the sample size. I'll do that in the chat here so we can see it. I'll show the detail 1 plus 2 plus, no, 1 plus 1. See, already made a mistake. I have to be very careful. And then we divide by 4, of course, and we get a 2. I know you could have done that in your head, but there it is, something to look at. Now for the standard deviation, I have to be put in a little bit more effort. I have to look at the deviation from the mean and find a score for each one of those. So I'm just going to write it like this, give myself some space here. I'm going to do it for the first one and then write down the rest to save yourself the hassle of watching me do it, but I will assume that you verify each of the numbers. Let's do the first one. Some spacers here. So everything's nicely lined up. So the deviation from the mean, so the x-score minus the mean will be -1. Then I'm just going to do it like this because I don't have a space. Then I'm going to square that to get, in this case, just a 1. And then if you remember, how do I get a z-score? Well, go way back. Over here, we take the x-score, subtract the mean, divided by standard deviation. So we have to calculate the standard deviation first of our sample. So it's the sum of all these squared deviations divided by the sample size. So the standard deviation comes first. So I do it for all of these. It's easy enough, so let's do it for this one. So I get a x. This one's going to be exactly the same. So it's going to be a 1. 2 minus the mean of 2 is 0. So that's going to be a 0 because 0 squared. And then 4 minus 2 is a 2 that I square for a 4. So when I add up all of those, remember the formula, sum of the square deviations divided by sample size. Let's see what we get. I'll show this one. This is our first one, but it does get a little tedious here to do by hand, so I'll cut it short for the next one. But I'll show this first one. We get 1 plus 1 plus, add up all the deviations, and then we divide by the sample size. So we get 1.5. We have to remember that, just as the formulas here suggest, the sum of the square deviations divided by the sample size is the variance. I may have misspoken there. Variance is what we're calculating here as 1.5. I'll dip into my scatter plot graph here. So to get the standard deviation, I have to take the square root of that 1.5. So let's do that in the chat here. And we get a 1.22 rounded. Now, same as before, because we're just doing it by hand, getting the progression through a typical question. We're not obsessed with accuracy right now. If you want to be accurate, you wouldn't do it by hand. You would use software. So for now, I'm just going to round as I go, understanding that that rounding error could get potentially much worse, and I won't know. But that's what I get when I do it by hand. It's more the progression through this than the actual number, as long as I make that agreement. Okay, we're going to round throughout, and we understand what we're going to get. Okay, so just a little disclaimer there. So now for the z-score, it is this exact formula, 3, 1. Take the x-score, subtract the mean, and divide that by the standard deviation. So let's do the first one here. So we have, I'll do the detail, we have an x of 1, take away the mean of 2, and then we divide by the standard deviation, 1.22, and we get negative 0.82. Now the next one has the exact same x-score, so it'll be the exact same. But I want to give you an opportunity to calculate the other two. Try yourself, see where you're at, and then we will write them down and you can verify if you're on track. So pause the video if you need to. If it takes you longer, totally fine. And see if you can get the next two z-scores, and we will be right back. All right, we're back. And hopefully you got a 0 and a 1.63 as well. Same as we did up for the first two. So now we have all the z-scores for on the x side. We want to now do the exact same thing on the y side. We have to calculate the mean, where we add them up, divide by the sample size. So let's do that. Together, 10 plus 8 plus 4 plus, well, negative 2. I'll just go minus 2. And then divide by 4. The whole point of doing these by hand, slowly together, as our first problem, is to have a reference, a template that you can build on and go faster the more you do it. First one doesn't have to be fast. Then, of course, in order to get the standard deviation, we're going to have to go through the variance. And for that, I'm going to look at the deviation from the mean. For the first one, it would be 10 minus 5. So that'll be 5. And then I'm going to square it for a 25. Okay. Next one would be 8 minus 5 will be 3. Square that for a 9. 4 minus 5 will be a negative 1. Square that for a 1. Last one, negative 2 for y. Minus 5 will be negative 7. Square that for a 49. And then we add up all these square deviations, divide by the sample size, and that'll give us our variance. So let's do that together. 25 plus 9 plus 1 plus 49. All of that divided by 4. And we get a variance of 21, which means the standard deviation is simply the square root of 21, which is roughly 4.85. 4.85. Then to get the, before I combine them, to get the z-scores for the y variable, we again think of this formula. The raw score minus the mean over the standard deviation. So let's calculate this first one. Raw score is 10 minus the mean of 5 divided by 4.85, the standard deviation. And we get a 1.03. 1.03. And we can calculate, let's do one more. Raw score, which will be 8 minus the mean of 5 divided by standard deviation 4. I think I swapped the 5 and the 8. Yes, I said 4.85, but it's 4.58. Let's back that up real fast. I, of course, did that on purpose to demonstrate how easy it is to make a mistake. All the mistakes here are on purpose. So we're backing it up. We wrote 4.85 instead of 4.58, which does affect everything a little bit, and you're going to be a little off, even with disregarding rounding. So let's go back and do that first one properly. It is the score minus the mean divided by our standard deviation, 4.58. 1.09. I could edit that out, but I'm going to leave it in to demonstrate that it's so easy to make a little mistake, and you have to always think, what am I doing? Am I taking the right numbers? What am I calculating? Constantly, because as soon as I shut down my thinking, even for a second, little mistakes happen so easily. I'm not immune to that either. Let's do the next one, where we have a raw score of 8 minus 5 of the mean divided by 4.58, and we get a 0.6, let's go 6, rounded to 2 decimal places. Now, again, like before, I'll give you a second to see if you can calculate the other two here. So pause the video if you need more time, it's totally fine. And let's see what we get. And we're back. So let's see if you get negative 0.22 and negative 1.53 for the other two. All right, so now we have our two sets of z-scores. We're going to multiply them pairwise. Let's do the first one. And we get negative 0.82 times 1.09, 0.89. You see how this topic, and you'll see the next one as well, it's a lot of hassle, to be honest, doing it by hand. So really be careful and show your columns and do the calculations carefully. It's very easy to make a mistake because there are so many of them when we have to do it by hand. Of course, this is forcing us to do it by hand. It's just forcing us to really understand the process through it, because when we use software, we don't see all the detail and how and why it works. All right, so let's again pause if you need to and see if you get the next three as negative 0.53, 0, and negative 2.49. Now we're going to calculate, we're almost at the end now. We're going to calculate the correlation coefficient, formula 11.1 here, by adding up all those and dividing by the sample size. So let's show that in the chat. That's kind of the last one. So we have a 0.89 minus 0.53, all right, plus 0, minus 2.49, and we're dividing by 4. What do we get? That does not look familiar at all. Just check if I did that right. The first one's a negative, that's why. Did that not show? Let me recalculate this first one. In my notes, I have a negative there. Yes, of course. Did I not multiply that right? Where am I in the chat now? Discord doesn't show it. Oh, it did. It did. I just didn't write it down right. I'm all over the place today. Must be Monday. And it is. So let's just check. It did show negative 0.89. It did. And negative 0.530 and negative 2.49, which of course affects my calculation for the correlation coefficient, changing it from a positive to a negative has a drastic effect. Then we get the much more correct negative point, I'll go 9.8. All right. I apologize, but it is worth seeing. My incompetency has benefits. It's worth seeing how a little typo or a little copy mistake or something can just be disastrous. A little negative. It wasn't my calculator. I didn't write it down. The correlation coefficient is completely wrong. Very important to always take your time and be careful of every step. All right, we made it one way or another. So our correlation coefficient for this sample is, by hand, negative 0.98. So now let's go back to the question. This question. Zoom in a little bit. A little more. There we go. There we go. So now I have to remember that that correlation coefficient is for my sample. I don't know if my sample is representative of all samples of dexterity anxiety scores. So we have a hypothesis test again to see or to test the significance of this observed correlation coefficient that we calculated. We could have had two very rare and extreme sets of anxiety and dexterity scores, giving us a correlation coefficient, of course, that we calculate in this way, but not representative of the connection and relationship between these variables in general. So there's still this sample element that we need to be aware of. So we have our hypothesis test that we want to set up. Our null hypothesis is that there is no true correlation, that the true population correlation coefficient is 0. And then, of course, that it's not the research hypothesis. And we're sort of hoping it's not, but we need to test, what does our evidence suggest? Is the evidence strong enough? We got negative 0.98. I don't know if that's strong enough. That's based on one sample. My degree of freedom for these sample size -2. And we have our significance level alpha at 5%. They tell me, or 0.05, depending on whether we talk about it or whether we use it in a calculation. So now, if I just visualize again, that was supposed to be a straight line. Let's try again. There we go. Visualize the t-distribution. It looks very much like curving back. What's wrong with me today? Let me be a little bit more careful here. Think of a bell curve shape. Same logic as the normal distribution, but it changes a little bit depending on the degree of freedom. Okay, so excuse me. So the true, under the null hypothesis, the true correlation coefficient is 0. We want to see, we then take a sample of 4 people, get a correlation between these variables. We want to see, is that too extreme, or is that something that I would get normally? and can therefore be taken as strong enough evidence that the true correlation coefficient isn't 0, but I get sample values that are far away from 0 or further away from 0. So I need to consider this one observation among all possible correlation coefficients I could have calculated from a sample of 4 people. They're distributed by all these possible correlation coefficients are distributed by a t-score. So I'm going to calculate my t cutoff depending on my choice for alpha, and because of the research hypothesis, it's going to be a two-tailed test, so I'm going to have 2.5% in each tail. But for the t-test, for the t-tables rather, all of this is done for me already. Zoom in a little bit. Because there's so many, they summarize it quite a lot. So I'm looking at a 5% alpha, two-tailed test, 2 degrees of freedom, 4.303. So that'll be plus minus 4.303. Now I need to calculate what is my observed t-score that corresponds to the correlation coefficient. Now, unfortunately, I looked at it again. I just assumed it was in here. It is not in the formula sheet, unfortunately. But we will write it down here. The observed t-score is calculated as correlation coefficient with maybe a straighter line divided by the square root of 1 minus r squared over n minus 2. So if I plug everything in, let's see what we get here. Carefully calculate that. Fraction first. So what is my r? I've used rounded numbers every time, so there's no reason to stop now and do negative 0.98 divided by something much scarier looking, the square root of, first one, 1 minus the correlation coefficient squared. Then still inside the square root, I divide by n minus 2. Now n is 4, so that'll just be a 2. And we get negative 6.96. So the left cutoff is negative 4.303. This observed correlation coefficient, when we sort of quote-unquote standardize it to a t-score, puts us more extreme at negative 6.96, further away. So now I conclude that yes, this is significant, that I wouldn't just randomly get these correlation coefficients from samples of 4 people, unless the true correlation isn't over here at 0, but in fact, well, technically different, but it looks like to the left. So we can write down our conclusion. These are a little bit longer because of all the detail in the calculation we have to do to get the correlation coefficient. That slows us down significantly. But always be aware that the hypothesis test is still there. So we can say something like, since t observed is less than the negative t cutoff, we reject the null hypothesis in favor of the research hypothesis. The evidence is strong enough to suggest that there is a negative. Well, technically there is a correlation between dexterity and anxiety. We set it up as a two-tailed test, so we can't really say which direction. If we then suspect it's going to be negative, we can make that a less than and do a one-tailed test. So you have to be aware that your conclusion fits with the hypothesis test. So let me be precise and just say a correlation. But we suspect negative, and then we can test further, right? Between dexterity and anxiety. Now, they didn't really tell the whole story here. Where does this test come from? What kind of dexterity, fine motor skills, what could it be, right? So we don't really know the full story. Not formulas, I'm looking for the question. So just to end here, now we have talked through this, so I'm not going to write down like we usually do. The logic behind what we did, we've talked about it, so you can summarize that if you want to. And in F, we just want to be aware that this does not imply causality. There is a connection based on this evidence. There is a connection between dexterity and anxiety. It doesn't say what that connection is. There are three possibilities: that dexterity directly affects anxiety, that anxiety directly causes or affects dexterity, or that some third variable affects both. And they're sort of connected when I look at the two of them by way of this hidden third variable. So be aware, as we've said before, that correlation does not imply causation. This does not mean that one causes the other, just that they are connected in some way. All right. Little mistakes aside, that gets us to the end successfully. Make sure you can do these calculations by hand. It is the place we should start before one moves to software and streamlines it. It's important that you see the detail, at least in the beginning. Make sure that you don't make little mistakes. I've demonstrated how easy it is to make mistakes. There's no embarrassment. It happens to everyone. As long as we are aware of it, we can avoid it successfully. All right. That brings us to the end of this video. Let me know if you have any questions. And we will talk again soon. Until then.